All right, so on Monday, we were able to get through a bunch of 7.1, but we weren't able to finish these last two questions right here. Okay, so we're going to finish up today with example 9 and example 10. And we'll work through these just so we can kind of see a flow for how things work. Okay, so for example 9 over here, right, it looks really complicated, and I would say if we were to think about which side is more complicated, maybe we would say the left-hand side is more complicated, okay? Now, one thing that is nice is that we can take these two fractions on the left-hand side, and anytime that we want to combine two fractions with addition or subtraction, what do we need to make sure we have before we can advance on that? Yeah, exactly. We need to make sure we have the same denominator, okay? So if we were to look for a common denominator, combine fractions and a common denominator, what would we multiply the first fraction by? Yeah, that 1 plus cosine theta. And what would we multiply the second fraction by? Yeah, we would multiply that one by 1 minus cosine theta, okay? So all that I'm writing in the purple is just the fancy way of saying 1 so that we can multiply and achieve a common denominator. And we're going to be super thorough in our work, and we're going to make sure we write down the equals the other side there. Okay. All right, so now if we know how to FOIL, or we know how to multiply out binomials, then we should be good to go, okay? And so if we combine our fractions over here, we're going to end up with one super long fraction. And the denominator of this fraction is going to be 1 minus cosine times 1 plus cosine, okay? And so I'm going to go ahead and multiply that out. I'll get 1 minus cosine squared theta. And that happens after I FOIL that denominator, okay? Let me pause here for a moment. Are there any questions about how I got to the 1 minus cosine squared? No questions? Okay. All right, so in the numerator, we're going to need to be FOILing as well, but we want to be really thoughtful about this. So we're going to take these first numerators from the first fraction and FOIL those out. And when we do that, we'll get 1 plus 2 cosine theta plus cosine squared theta. So all of that is from the first fraction, okay? Minus, when I FOIL the numerators on the other fraction, I'm going to have 1 minus cosine theta times 1 minus cosine theta. And so that's going to give me 1 minus 2 cosine theta plus cosine squared theta. Okay. Now, as I move into this next step, what is going to be really important as I simplify the numerator here? right? As I simplify that numerator, what's going to be super important to be aware of? Exactly, that negative sign, right? Gets you every time, even when you're looking out for it. So let's just make sure to note here that we're going to need to distribute that negative sign all the way through, okay? And so when we do that, we're going to get 1 plus 2 cosine theta plus cosine squared theta minus 1 plus 2 cosine theta minus cosine squared theta. Okay, so we're just cleaning up the numerator, but we really need to make sure we distribute that negative sign. Now, what can we do with the denominator as we start to simplify with that 1 minus cosine squared theta? Yeah, exactly. We can use our Pythagorean identity to go ahead and turn 1 minus cosine squared into sine squared. Okay. All right, now for the cleanup. Let's see. When we clean up everything in the top, well, this 1 and this negative 1 go away. This cosine squared and that cosine squared go away. And in the top, all we're going to have is 4 cosine theta over sine squared theta. And we want to make that equal to 4 cotangent theta cosecant theta. Okay. All right. So we've got one last step here. How do we make that left-hand side look like the right-hand side? Right? How do we make that left-hand side look like the right-hand side? What do you tell us what you mean by the cosine divided by the sine? Sine squared theta is, yeah, exactly. So it would be helpful to think about that denominator as like a sine theta times the sine theta, right? That's what we mean by the sine squared theta. That's perfect. And now I think it becomes a little bit more clear what you were saying before, that cosine divided by the sine. Exactly. The cosine divided by the sine is going to give you your cotangent. And then this sine on the bottom is really the same as 1 over sine. So that's where we get the cosecant from, okay? All right, so now we've got our 4 cotangent theta cosecant theta equals 4 cotangent theta cosecant theta, right? All right, so a little bit longer than some of the other ones we've done, but really a lot of those algebra skills we learned like way back when are definitely coming back into play, okay? So things like finding a common denominator, being able to FOIL, distributing that negative sign, all those kinds of things definitely still come into play, okay? All right, any questions about number 9 before we take a look at number 10? All right. All right, let's take a look at example number 10 then, okay? So what are some ideas that folks have here around getting this left-hand side to look like the right-hand side? I know it's a lot of letters, but what might be a good first step here? Okay. And what do you propose we do with those exponents? Yeah, we could distribute them. Okay. So when you say distribute, you mean like this, like square this term and square this term? Hmm, okay. Well, bad news for you. That's exactly the wrong thing to do. Okay, so we don't want to distribute in that sense. We need to be super, super careful about that. Okay. What we want to do though is we want to think about, yeah, multiplying them together or foiling them. Okay, so whatever you kind of need to think about there um, to get yourself away from that distribute that power. All right. So I would maybe not write that, but I would write that I need to FOIL and that I need to FOIL. Okay. Does that make sense, folks, about why we're not just distributing that square? Yeah, exactly. We're looking at the whole thing, and the real key indicator here is that we have a plus and a minus in there, okay? And so this first step actually gets pretty messy. We have 2 sine theta plus cosine theta, and we have to multiply it by itself, right? So that's sort of the expansion of the first one. Plus, we got to do the same thing with the second set, 2 cosine theta minus sine theta times 2 cosine theta minus sine theta. And that's hopefully going to somehow equal 5. Okay. And you thought, I just want to make it really clear to folks, right? Why yes, that's the rule. A plus B squared equals that. So that's definitely a rule we want to remember. But part of that is remembering the rule, and the other part is remembering when to use that rule. Okay. So I just want to write this out to be clear about when we use the rule. We can certainly use your shortcut there process, right? But I think what also makes that a little trickier is we've got, instead of just a sine theta in the front, we have a 2 sine theta. And so we want to be careful when we multiply those out that we're multiplying in those coefficients as well. Okay. All right, so if we FOIL out the first terms and combine some like terms, we're going to get 4 sine squared theta plus, let's see, the outer terms multiply to be 2 sine cosine, and the inner terms multiply to be 2 sine cosine. So I'm going to get 4 sine theta cosine theta plus cosine squared theta. Okay, remember, no one is going to write cosine theta squared. We're going to write the square in between, so we know we're actually squaring the cosine. Okay, and if we do the same thing over here, we're going to get 4 cosine squared theta minus 4 sine theta cosine theta plus sine squared theta equals 5. Yeah, you can definitely use the box method here if you prefer to keep things organized. And so maybe what that might look like is having like 2 sine theta plus cosine theta, 2 sine theta plus cosine theta. And when you fill in the inside of the box, that should give you the same thing as these 3 terms here, okay? And if you do the same thing with the other side, you should get these 3 terms over here. Cool. Okay, so now that we have this, how do we move forward from here? What are some things that we can do to simplify this? Because we got to get down to 5. Like, there's not even a trig function on the other side. It's just 5, just a number. Okay. So let's see, we've got a 4 sine cosine, and we have a negative 4 sine cosine. So those are going to definitely go to 0. Exactly. Okay. And so let's see what we have left. We've got 4 sine squared theta plus cosine squared theta plus 4 cosine squared theta plus sine squared theta equals 5. All right. So what do we do? Pythag. All right. So tell me what you mean by that. Okay. So like cosine squared plus sine squared, right? Maybe let's write those in the front. Sine squared theta plus cosine squared theta. So I'm just sort of rearranging the term. And we should recognize that this is the Pythagorean theorem. And so in our next line of work, that's just going to equal 1, okay? Well, what about these other folks here? 4 sine squared and 4 cosine squared. Well, 4 times that, right? 4 times that will equal, okay? And we can use our Pythagorean again here. And so we end up with 1 plus 4 equals 5. And we do get 5 equals 5. Okay. So looked like a real big problem, right? With so many letters here. But in the end, at the end of the day, they actually just equal the number. Can you not combine the 5? Yeah, of course, you could do that as well. You could combine your like terms, all right? So just to clarify what Eric is saying here, I think he noticed that there's 4 sine squared and a 5 and 1 more sine squared, which would make 5 sine squared. And you could follow that same pattern for the cosine squared. Yes, and then you could sort of factor that part out. Okay, so that is totally a reasonable way to finish off the problem as well. All right. Any other questions here on number 10? All right. Well then, we're going to stop this video here.